This program is a presentation of UCTV for educational and non-commercial use only.
Good afternoon. My name is Ellen Gobler, and I manage the Graduate Council Lectures. Thank you so much for joining us today. It is now my pleasure to introduce Marjorie Shapiro, Professor of Physics and past Chair of the Physics Department.
So I'm very pleased to be able to introduce to you today, for his second lecture of the week, Professor Leon Lederman, physicist, Nobel laureate, former director of Fermilab, educator, and author. I'm not going to give you a long biography of Leon because his talk today is really going to talk about his life, and he can tell you about it much better than I can. But I did want to say that I first met him when I went to Fermilab as a postdoc in the 1980s, and it says something about Leon, first of all, that I always called him Leon, even though I was a peon of a postdoc, and he was the director of Fermilab at the time. And second of all, that I always felt very comfortable talking to him. He was somebody who used to eat in the cafeteria every day, and if you had a question about physics, you could just plop down next to him and ask him a question, and he would talk for hours. He loved talking about physics, and he really felt that it was an important part of Fermilab that everyone feel that they were part of the community. So as I said, the lecture today is really going to be about how Leon went from his start as a physicist through all of his great discoveries. But as somebody who saw those discoveries both in the past, because some of his largest discoveries had happened when I was still a young student, but also saw them come to fruition later on, I just wanted to make sure it was clear to those of you who aren't scientists in the audience what a pivotal role he's played in the history of our field. The era where Leon was doing most of his science was an extremely important one. It was one where we went from having almost no understanding of what we now believe are the fundamental particles to where we have a picture that, although it isn't complete, allows us a framework for really describing what happens on a subatomic scale, hopefully all the way up to very high energies and to what could happen in the early universe. And Leon played an important role in the discovery of several pieces of that. The thing he won the Nobel Prize for, the discovery of the muon neutrino, is one of the things that told us that matter had many copies of itself, that there was more than one family or generation of particles. And then later on, he showed us the same thing was true for the quarks as well as for the leptons, as being the person who led the team to discover the bottom quark. He also played a very important role in making sure that the appropriate facilities existed to do that science. He was instrumental not only in discovering the neutrino, but in understanding how to produce beams of neutrinos. And when he was director of Fermilab, he was there during the construction phase and the initial operations of the Tevatron, the proton-antiproton collider that's been the highest energy accelerator for the past 20 years and will continue to be until the turn on of the LHC, hopefully at the end of this year. So with that, let me welcome Leon, and I hope you all enjoy the talk. And at the end, we will have time for questions, but I'll step down now.
Are there any questions? Well, I hope there'll be questions. Let me be comfortable here and hope you all are comfortable too. So I'm going to ramble, and I hope somewhere in this I will talk about physics and my experience in physics. But let me begin with a story. I was a graduate student at Columbia University. That's somewhere in New York. And we got a telephone call from a friend in Princeton asking whether we would like to meet Einstein. And we said yes. A friend and I thought this was a joke. You know, could we possibly meet Einstein? Is that doable? And our Princeton friend said, oh, yeah, he goes to lunch every day, and if you sit on a certain bench, I'll show you where, he'll pass by, and maybe, you know, he'll feel like chatting with you. So we drove down to Princeton and found the bench, and we were told to sit here and wait for the greatest physicist to pass by. And sure enough, after a little while, there he came with his research assistant, I think, and there he was with his baggy pants and sweatshirt and sandals, I guess. And as they came close to us, we heard his assistant say, would you like to meet some students, Professor? Yeah, he said, yeah. That meant yes. So we sort of jumped up, and he stopped with my friend first and said, what are you doing? That's German for what are you doing? And my friend said, I'm doing a thesis on quantum theory. Ah, said Einstein, you're wasting your time. And I felt a little better because I'm an experimentalist, so I was doing experiments. I told him I'm working on the properties of pions. Ah, he said, pions. We don't understand the electron. Why do you waste time with pions? Okay, boys, goodbye, he said. And he walked off. He had disposed of 2 brilliant, handsome graduate students in 30 seconds. But we didn't care. We had exchanged words with the greatest physicist of our time. So we were really very happy. It was quite an experience to have that. And I don't know if anybody here is old enough to have met Einstein. Bruno, did you meet Einstein? You see? Okay, so I'm unique. I talked to Einstein. It's it was quite an experience. Being a graduate student, I had spent some 3 years helping a guy by the name of Eisenhower with some problem he had in Europe. And it was called World War II. And so I had, and then as soon as I was able to manage being discharged from the military, I rushed to Columbia and registered as a graduate student, and started to study physics again. And I think that was probably the worst year of my life because I had forgotten how to study. I had spent 3 years doing totally irrelevant things. And all of a sudden I was back to studying and had forgotten how to study. I'd forgotten that physics was fun. I was having a terrible time. And several times considered that maybe I'm doing the wrong thing, you know, working on trying to get an advanced degree in physics when I didn't really know much about it. I had forgotten, and that was a very, very hard experience for me. And then something funny happened. I had been given a small room where I could begin to think about apparatus and think about doing some research. The chairman of the department was one of the founders of American physics, Isidore Rabi, and he had told me that this room would be the place where I would do some research. And I had been away from that room for a couple of weeks working on preparing for a major exam, and came back and entered the room, and there was a janitor mopping the floor and singing, obviously, some Italian song. And as soon as I came in, he sort of used his mop as a kind of a rifle. He held it and he announced in very loudly presumably his name. It was Bernardini. And I said, yes, that's very good, but be careful. That mop is wet and the wires there have electricity and you're going to cause short circuits. And he looked at me blankly, didn't understand a word I was saying. His English was not so good. But later I came out of the room and I decided to wait until the janitor was finished with his mopping. And Mr. Robbie was actually in the hall, and I said, I see you have a new janitor that doesn't speak any English. He said, you mean the guy in the room? I said, yes. Oh, he said, that's not a janitor, dope. That's Gilberto Bernardini, a famous cosmic ray physicist, and I hired him here so that he may be able to get you through your PhD degree. Oh my God. So I rushed back in to repair my damage and start to communicate with this guy, Bernardini. And that was hard because his English, I remember he'd come in the morning and say, good night, everybody. He was very friendly. But he was very funny. I watched him. I realized that he was a famous scientist. He had very curious activities. He would enter a room and push the light switch, and the lights would go on. And he'd look at the lights and he'd say, "Fantastico!" Now that's Italian. And I think it means fantastic. And then he'd turn the lights off, turn them on again, "Fantastico!" Turn them off, turn them on again. He kept doing this, Well, he seemed to think it's just fantastic that you can push a button and the lights go on. Come to think of it, it is kind of, wondrous that you push a button and the lights go on. I mean, we know that you could figure out that push the button and some circuit closes and 100 miles away a motor drives some electricity and eventually the lights go on. But it was, for him, what I call a sense of wonder. He'd push the button, the lights would go on. Fantastical. And that's what he had. Everything he did, he seemed to take a certain amount of amazement. So we started to communicate, and his English improved. My Italian didn't get any better. In fact, it was 0 to begin with, still is. But he was someone who took a great deal of joy. And then the first thing he did is he wanted to find out what was in this laboratory. And the thing that I showed him was my despair. I had built something called a cloud chamber. What is a cloud chamber? Well, it's a box about 12 inches in diameter, maybe 6 inches deep. And it's filled with some nitrogen gas and some alcohol vapor of some kind. And the notion was that if you pushed a button, the bottom of the chamber would collapse and the temperature of the chamber would change, and you were supposed to see tracks of particles. And all I got was white smoke. I tried and tried, and it was a failure. One of my many failures was I couldn't get this cloud chamber to do anything but white smoke. And Bernardini looked at the chamber, and he says, "What's that?" And it was a wire going into the chamber. And I said, "That's my radioactive source." Gilberto said, "Dig it out." I said, "But that gives me the tracks. That's radioactivity." He says, "Dig it out, take it out." So I took it out. Tracks, beautiful tracks appeared. My radioactive source was about 10 curies of some terrible ultra radioactive stuff that was killing the chamber. So we learned. What else did we do? Oh yes, then he showed me how to make a a kind of Geiger counter. So we did some machining. He showed me how to use the tools of machinery and string a wire through the middle of this copper tube, and there was little insulators, and the wire came out, and eventually we'd have the whole thing working connected to an oscilloscope, and we were watching the oscilloscope, and all of a sudden on the oscilloscope there was a sweep, and then there were little bumps, and Bernardini went crazy. "Is it counting?" He said, "Is it counting?" He starts screaming, and he was much shorter than I was and probably half my weight. He picked me up and started dancing around the room. "It's a counting, it's a counting." Well, this is a phenomenon he must have seen hundreds of times as a cosmic ray scientist, but he never got used to the notion that we were actually observing particles that came from millions and millions of miles away and came to the 10th floor of the Pupin Physics Building at Columbia University and said, "Buongiorno." That's what he said. He said he's saying "Buongiorno" to us, you know. It was kind of, again, a phenomenon that he must have seen, I don't know how many times, but never got used to it. He had this sense of wonder that you can actually observe this object that came from so far away. And that's what he would say. "He's come to say buongiorno to us, 10th floor Pupin, Columbia University." It was the beginning of a return to me of the fun of physics, because that's what it was. For him, it was a joy. And I kept learning from him how to also enjoy the physics. Little by little, that was something that restored my enjoyment, first of all, because he was a lot of fun. And he put on a lot of, he was a good actor in many ways. And I think he was doing a lot of this for my benefit. But it was certainly a learning process. I think I was very lucky to have that experience, because I needed that kind of restoration of enjoyment and fun. And the thing, though, that was most impressive was this sense of wonder about the world. He never got used to it. You push a switch and the light goes on. Fantastic. Fantastico, I should say it right. At one point, I remember he warned me that sometime, as when you're in physics, you're going to see something that nobody ever saw before. He sort of warned me about the joy of doing science and discovering something that no one has ever seen before. And that was certainly a major effect. And so I thought I'd tell you this story because it's illuminating to find out, had it been someone else, maybe a more conventional kind of guy who might have also been a good teacher, that might have helped too. But having this gentleman be so enthusiastic and so sharp in his enjoyment of science was, I think, crucial to my experience and my career. Some years later, I was now at Columbia. I was a professor. I was doing research. I had my own graduate students. And what he warned me of happened. It was 3 o'clock in the morning. I don't know why these things happen at 3 o'clock in the morning. I was doing an experiment. I was out in in the fields of Illinois, and I was checking apparatus. Graduate students had gone to sleep, and I was looking at the equipment and began to study some of the output from one of the computers, and it looked very funny to me. Something unusual was happening. And then out came what was something we had been waiting for, a spectacular track proving the existence of muon-type neutrinos. Let's never mind what that is, but it was something we possibly expected, and there it was. And all of a sudden, it was, it made you breathless. Your palms started sweating. You were nervous. Something was happening in this apparatus that was spectacularly beautiful, and its implications were very deep. It would make headlines all over the world, and it became hard to breathe. I tested things. I checked. Everything I looked at just confirmed that at 4 a.m. In a cold winter day in the fields of Illinois, I had good evidence of a discovery. I actually located Bernardini. He was in fact visiting in New York at the time, and I had a telephone number, and so I called him. I told him what I had seen. Well, by this time, many years later, his Fantastico had disappeared, and it was Americanized, and when I told him what I had found, out came, holy shit, no kidding. So that was a magical experience, certainly. Some years later, my wife Ellen, who's sitting out there, and I were in Sweden. Gilberto had come to help me receive the Nobel Prize. Gilberto's Fantastico was ubiquitous. He was very excited by this. And I said to Ellen, did you ever, in your wildest dreams, imagine that we would be in Sweden dining with the king and queen? And Ellen, very skeptical as usual, said, you were never in my wildest dreams. That's the way it goes. Okay, well, what can I tell you? Physics, the joy of doing physics, once you get to the knack and you're lucky. Luck is a very important issue. If anybody tells you what does it take, luck would be probably one of the first things you would opt for. Also, the other thing is your surroundings, and being at Columbia University was a fantastic experience. There was a sense of vitality to the thing. Times were appropriate. Discoveries were on the horizon. New apparatus was available. If I compare those lucky times to the poor opportunities we have today, certainly because of the economic crisis and the difficulties of pursuing experiments at high cost and complicated apparatus and so on. We were very lucky in those days, and the big problem today is to try to maintain, restore, and improve the opportunities for young people to have the kind of experiences I had in my graduate school days at Columbia. What else can I tell you? That's a major thing. I do want to say a few things about opportunities. One of the things that I got interested in and talked a lot about yesterday was science education. But what I didn't talk about is a school that I had the good luck and maybe a little bit of wisdom in starting in Illinois. It's called the Illinois Math and Science Academy. I was, as a director of the Fermi Laboratory, I was interested in students and in education, and we had a lot of opportunities to invite students to come into the laboratory and to take courses. There was Saturday morning physics courses, and out of that, a procession of young students that would come into the laboratory, and that kind of inspired me because I realized that the average schools in Chicago area in Illinois were not exceptionally good at teaching young people. And so I got involved in this thing and organized something called the Illinois Math and Science Academy, abbreviated IMSA, IMSA. It was a special school. I had to see the governor of Illinois. This is one of these governors who happens not to be in jail. I mean, it's unusual for Illinois, but this was an okay governor. And he was intrigued by the notion of creating a special school in Illinois. I told him about he knew about the famous Bronx High School of Science, and I said, we need a Bronx High School of Science out here in the prairie of Illinois. And he authorized the existence of a special school for gifted young people, in which the school itself would also be a place where students could live in. It was a residential public school that would carry students through the last 3 years of high school. And that opened in 1986, and first graduating class was in 1989. So it's well over 20 years now producing some of the most brilliant and students. These were all restricted to the state of Illinois by the law, but it was a fantastic experience, especially since within the last month or two, the Intel Foundation, which Intel is a huge electronics company, and they spend a lot of money on education, on science education. And they organized a study of schools, and I was very happy to learn not so long ago that the Illinois Math Science Academy was given what's called the Intel Star Innovator Award, and as the best science high school in the nation. They had tested some 700 schools for us to win this particular award, which was certainly gratifying. Some of our graduates, by now have had huge careers in science, but not only in science, but in all subjects. But the notion of giftedness and taking care of this idea that young students who have a gift should be encouraged in the best possible way was something that I believed in and still believe in this. And the Illinois Math Science Academy is a fantastic school. If you're ever discouraged or feel that you need to cheer up or so on, I invite you to come and visit the school. It's about 30 miles west of Chicago, very close to the Fermi Lab, where you could also invited to visit. But the school itself has this fantastic group of students that are increasingly making their way in the world. course, this is a high school, but the push they get towards higher education is enormous and gratifying. And every time I feel I need more encouragement, I go to the school and sit there and chat with the students. We now have 4,000 graduates. We graduate something like 200 or 300 students a year. They go to the universities everywhere. I'm sure there are many of our students are here at California. But to take special care of giftedness is an important thing. It's not the only thing you want to do in education, but it is an important issue because these are the students who will become the doctors and the wise people that will sustain our society in the times to come. The Illinois Math Science Academy has projects, and one of the projects we had was for each of these students to pick a famous scientist and write a biography of the scientist. Now, it's interesting that when you challenge them to name a famous scientist, and I say, nobody, present company, just pick a name of a famous scientist, they were silent. They didn't know any names of scientists. So I said, okay, well, you have subjects you like, look up the subject and find the scientist who's active in that subject. And eventually, they did. That was one of our interesting projects because there were 15 students and they picked 15 scientists, and I told them that they then did research on what the scientist had done, and at some point I said, you have to interview the scientist. Well, how do we do that? So I called up a lady by the name of Claudia Dreyfus, who writes for the New York Times, and she writes an article periodically, a biography of some living scientist. And she came and very kindly gave these kids a lecture on how you interview scientists, what you ask, how do you ask questions, how do you keep the conversation going. And as a net result, each of these students wrote an essay. I warned the scientists that they picked, the ones that I could reach on the telephone, you may get a funny telephone call from a high school student. Please be kind, he's going to write a biography. And eventually, that's what happened. They wrote biographies, and I put them together and called a publisher I knew, and he said, oh, he'd be delighted. So there's a book called Structure, or I forgot the exact title, but it had to do with famous American scientists. And each of these kids is now an author of a book. The book has these delightful stories of the scientists. Kids emphasized, of course, the high school experience of the famous scientists. I think you must know some of them here. Charlie Towns is in the book. And these students wrote a really lively story of these scientists. That was one of the projects the students had. Again, I wouldn't mind answering any questions or listening to better stories on experiences of various kinds.
Einstein has said that David Bohm is his intellectual successor.
Yes.
So what do you think about David Bohm's quantum theory?
David Bohm. Well, he's a very interesting guy, but I think if you want to learn quantum theory, there are probably better educational books on quantum theory now. I think his book is rather old, and I don't remember. I can't really tell you whether it was one of the better books, but by now you can find some really good quantum mechanics books available that are more modern, more up-to-date. David Bohm was an interesting guy, but that's a complicated story of his problems and so on. I think he was actually, when he was in real political troubles, many of us were very sympathetic to his point of view.
Hi, I'm Cheryl She from the Exploratorium, a museum in San Francisco that was founded by Frank Oppenheimer back in 1969. And I'm wondering, did you visit museums when you were a kid? And did you know the Oppenheimer brothers? And if you can tell some stories about that.
Museums, yes. There was New York. Lived in New York City, and we had a plethora of museums, and I loved to go to museums, especially the Museum of Science and Industry in Manhattan. And I certainly went to museums. Now, you asked about Oppenheimer. I knew both Frank Oppenheimer and what's the Robert Oppenheimer. That was part of our life. It was a political problem. The story of Oppenheimer is well documented. There are several books on the subject. He was, of course, a heroic figure in World War II, having led the research which led to the nuclear bomb. Then he was, I think, dumped on by because he was a free thinker, and although he made a huge contribution to the war effort in World War II, he was unpopular in the military, and they eventually, for reasons which were very complicated, his efforts to help the United States were thwarted by people who thought politically he was not correct enough for them. And so he retired to Princeton, where he was director of the Institute for Advanced Study. But his scientific career was sort of ended by a traumatic experience he had politically.
Leon, I wondered whether you'd talk to us a little bit about your experiences in the end of 1956, when violation of parity was discovered.
56, parity, yes. Let me try to remember what happened. I'm really drawing a kind of blank as to the sequence of events which led to.
Let me ask more specifically. I mean, when did you hear about Madame Wu's result, and when did you start doing experiments yourself? And what did you know about other people who were racing to get the result at the same time?
Yeah, well, we had the big benefit at Columbia of having Tsundao Lee, who was a professor of physics at Columbia, and he was one of the authors, along with Frank Yang, of the notion that one of the basic laws of physics, which we all believed in, which was conservation of parity, might not be actually valid idea. And there was evidence, if I remember right, from various experiments to indicate that perhaps one of these basic sacred laws of physics we all thought was certainly valid might, in fact, not be valid. And and they gave a series. They actually proposed a series of experiments that might test the validity of this notion. One of the dramatic consequences of this has to do with with mirror symmetry. If you look in a mirror, let's say one wall of this room is a mirror, and all of you guys are doing experiments, and the guys in the mirror are, of course, doing the same experiments. The question is the symmetry such that both the mirror experimentalists and the real experimentalists get the same results? And 99% or more of physicists would say, of course, you must get the same results because that's just the mirror image of what's going on here. But much to everybody's surprise and to the wisdom of Li and Yang, they decided that perhaps the symmetry was not perfect, that there was a violation of mirror symmetry, and that the mirror world was not precisely the same as our world. And they made that part of their paper, which gave rise to the notion of, well, can we check this experimentally? And of course, the story was that when experimenters, now full of doubt about the validity of mirror symmetry, went at it and made tests, we found, in fact, that the symmetry between the world and the mirror world was not perfect, but it was imperfect. That was a major discovery because for 50 years or so, people believed that the mirror world and the real world were identical. You know, how can it be different? But it turned out that it was known as the mirror symmetry was broken. It was not a correct symmetry, and that made a big change in our philosophy of how particles behave. That was very exciting. You know, every once in a while, you get epochs of great excitement in physics where you rush in to do an experiment and you are not sure you know what the results will be. And it's the greatest joy when, in fact, it turns out that the kind of results you expected don't turn out to be the correct results, but something totally different takes place. And that's what happened during the parity days. We discovered by careful experiments that the mirror world and the real world are actually different. There are differences. And that was a period of great excitement. Now we're used to it. We understand the violation of mirror symmetry. Yeah.
Professor Lederman, what do you remember? What were you doing?
Make a little space between you and the microphone.
What were you doing when the Nobel Prize committee notified you have won the Nobel Prize? And what's your feeling in the first time?
I think let me say that winning the Nobel Prize is something I recommend very highly. It really is a lot of fun. Probably, as usual, it happens late at night. You get a telephone call. I think in this particular case, or one very much like it, my wife had the phone, and we sort of suspected that there would be an award. It was rumored and so on. And she got the telephone call, and she said to me, "We can't go to Sweden because I have a dinner date that night." And she handed me the phone, and she was kidding, of course. So I recommend winning a prize very highly. I think it's a great thing to do.
I was actually a student of yours at Columbia.
You were?
Yes.
Oh, yeah, you sat in the third row.
You gave me an A+ in Physics 8 in 19, but, and was an undergraduate and graduate student. During most of those years, I got my PhD with Charlie Towns, and it was amazing to me, and people have remarked on that, that almost every professor I had who had, won a Nobel Prize, and I was wondering if you had, when you were there, had a sense of this being some sort of golden age, or the other people being...
Well, as a graduate student at Columbia, we had a button made which we wore occasionally called "Not Yet." And that's because the faculty at Columbia was loaded with Nobel Prize winners. There was Robbie, there was Towns, there was Willis Lamb. There were, it was just a star-studded faculty. And so the graduate students would, feel a little bit awkward about this, so we got this nice button saying "Not Yet," which was a sense of wild optimism that something good would happen to you. But
Yeah, I think of two experiences. First of all, I had a lab on the 10th floor of Pupine also.
Oh, yeah.
But I remember one morning doing experiments, staying up at night, and coming down the elevator, and I was in the elevator with Lee and Cush and Robbie, actually. And
Three Nobel laureates.
yeah, I couldn't resist. It's the only time I had that much chutzpah. I couldn't resist saying, "Do you guys realize I'm the only person in this elevator who doesn't have a Nobel Prize?" It's a gutsy thing for a graduate student to say.
Well, it was a great department, and having those people around was a fantastic experience. And even somewhat lesser creatures like the Bernardini story, who would always say, "Fantastico!" What you learned there was a sense of wonder in physics, that you learn something and it's just beautiful. That, in fact, was a comment made to me by some time ago by my senator in Illinois, who's now the President of the United States. And we had a conversation on physics. He seemed to know a lot about it. And what he said was amazing to me. He said, "The thing about science, and especially physics," he says, "is when you guys make a discovery, it turns out to be beautiful." Now, that was a surprise, because to say that something in physics is beautiful is something that physicists say all the time, but not when outsiders are listening. You don't want, you're bragging about the fact that the subject is beautiful. But here was a layperson, in a sense, who recognized the beauty of science. So I'm very happy about having him in the White House, taking care of, hopefully at some point, supporting the increase that he really understands we need in research and education, which is what we're all devoted to.
I have to say, I remember among all the professors that you really communicated that. I think this was I don't know, there was some sort of honors physics for smart freshmen and like sophomores, and I think the last semester was optics and atomic physics or something. But maybe that was the most beautiful of the three subjects.
Right. There's a guy behind you who's big, and I would get out of his way.
Professor, what in current physics research do you find particularly exciting? Now? Yes.
Oh gosh, well, I think it's very clear to me that we're in an epoch, I think, of incredible discovery. You can take a deep breath and you sort of can sense discovery in the air. Part of this discovery comes from astrophysics. There's a new subject called particle astrophysics. It's the particles are the smallest things we know about in the world. And the astrophysics are the large things that have to do with galaxies and stars and so on. These two subjects are sort of joined by phenomenon that bridge both subjects. And so this is a very exciting time, and what will cap the excitement will be the new machine that's under construction. Hopefully, we'll start working within the next months in Switzerland, in Geneva. The Large Hadron Collider, it's called, that's going to be like a new telescope. Remember, Galileo, made a telescope and looked up and discovered the moons of Jupiter and so many things. In fact, started scientific astronomy. And this new machine that's under construction in Europe, which is now participating, so all of the major nations are participating in this, will certainly give us new phenomenon and will help us understand many of the puzzles that are bothering us right now that have to do with astrophysics and dark energy and dark matter and phenomenon. And we're in an exciting time. I wish that economically we would overcome our present difficulties and begin to really accelerate the kind of research that will reveal what's going on. Yeah.
Leon, when you were a kid, was there some experience or a
I'm still a kid, huh?
Oh, that's right, but that started you down the path to become a physicist instead of, say, a Wall Street wizard? So.
I tried Wall Street, it didn't work. Why did I get into physics? Actually, in the beginning, I was in high school and early college, I was a chemistry major. But little by little, I turned to physics because chemistry was complicated and physics was simple. At least so I thought. And the physicists in the area were more dynamic, if you like. And physics had a great attraction because in some ways it was very simple. You dealt with a particle, or two particles, and so on. And chemistry was very complicated with all kinds of molecules sticking out in all directions. So I thought physics had a kind of appeal because of ultimately it looked for the simplicity and tried to make the most of understanding the world that we live in. So I think that was for me a very good choice is to stay with physics. Well, some of my best friends talk to chemists.
When you think back to the history of mankind, can you mention 2 or 3 inventions that were most beneficial?
Inventions. Well, inventions sort of imply something that's useful, like, I don't know, automobile invention. That's a good question. If I can think of discoveries, maybe that's a better word than inventions. And clearly, the fact that we can understand so much of the world in which we live is already a discovery. I think that's important to know, that we can understand, we can predict Halley's Comet will appear 2061 at 3 o'clock in the afternoon on a Thursday. And pretty much we can get it right. So we know a lot about the world in which we live. But there are a lot of things about the world in which we live that we don't understand. And the challenge of understanding those is very great and important. We have lots of problems facing us in environmental problems and social problems and economic problems. And but understanding the world, I think, and understanding the world in which we live in a thorough and deep way is one of the major tasks we have. And this is something that mankind has been concerned with for a long time, and it's still there, that we do have so many things we need to understand better than we do now.
Okay, with that, I'd like to thank Leon for his talk and thank all of you for coming.